Hello friends, in this lecture we will see what are some of the tools and techniques that we can employ for maintenance of our file systems. And file systems can also become kind of sick. They can become overloaded with maybe too much data, or maybe they are tuned inappropriately, or they can become corrupt because of maybe buggy utilities or maybe some driver issues or certain hardware errors. So if we have got file system which is this sick, we can use certain tools to make it a happy file system. So now, as you know, that file systems are basically just big data structures which are used for storing files on the disk, and also an indexing method that makes it easy to locate the data at a later time. Now, every file system has got some flaws. Besides the facilities and the features that it provides us, it also has got some shortcomings, and those shortcomings could be like inconsistency in the data, or maybe it is chewing up too much of the disk space. But we have got some tools in Linux that we can employ to help mitigate some of these problems, and some of these tools are tune to file system, and other one is debug to file system, and another one is dump E2 file system, which are specifically for extended to file systems. Now we can use this dump E2 file system command or tool to get the information not only about extended 2 file system but also regarding extended 3 file systems. But these two commands, tune to file system and debug file system, I must warn you that this is only for experts, because it does take into account a lot of information and is really not suitable for beginners or starters who are just into the Linux operating system. But you can use this one, tune to file system or tune to FS, to tune certain parameters like adjusting the maximum mount count. And what it would mean is that how many times your partition or your file system should be mounted before it is automatically checked for integrity using file system check utility. Or you can also adjust how much time should be passed before automatic file system check is implemented. We can also use an option as -J or capital J to make extended 2 file system into extended 3 file system. So we can tune our extended 2 file system with -J option to convert it into extended 3. Or we can even set the number of or even percentage of result blocks of a file system. If we have created XFS or extends file system on a Linux machine, then we can use XFS info command, which is XFS_info, and then the path of that particular partition. You may not find this XFS utility in some of the Linux distributions, like it's not available by default in Debian based distribution, but you can install it. So now let's go ahead on the terminal and let's see some of these commands and their outputs. Now I have this small SSD drive inserted into the Linux machine, and let's just try to see what information we can get out of it using the dump extended to file system command that we have just seen. So I type in sudo dump and E2 file system, and then the partition, which is sdb1. So we see a lot of information is there, which is kind of cryptic for a normal user. So what we can do is that we can add a switch which is for -H, which is for more human readable format, which is over here. And if I bring it up a little bit, we see that file system OS type is Linux, file system is in clean state, and also some features like extended attributes, resize, inode, directory indexing, file types, all supported in there. We can also see the inode count and block count, and also we can see the maximum mount count is -1, so that it does not need to scan these small devices. We can change it using the tune to FS option. We can also see that for this SSD drive, the check interval is 0. Now we can also use the command which is sudo and debug filesystem dev sdb1, which takes us into interactive mode, and from there we might want to change the or tune the file system as per our requirement. But I would suggest that if you need to tune your file system, which is really not required until unless you are really delve deep into the file system and you really want to tweak into it, because frankly speaking, I have not seen many administrators, including myself, using these utilities. But if you want to use it, then make sure you first go through these manual entries, like for tune to file system. Tune to file system, you should better read it before you implement or execute this command to change the parameters which are supported over here. For example, you can change the max count, interval between checks, error behavior, general options, and other such functions that are available. Likewise, if we have created a file system using XFS, then we can use the facility which is XFS info, which is not available by default since I have not installed XFS file system. But if you have got XFS, you can use the command xfs_info and then the partition and it will show you the information more or less in the same way that you have seen over here. Now, besides tuning the system, if you have installed extended to file system, then since it does not support journaling and lacks the capability to know if an inconsistency or a corruption has occurred, you might want to use file system check from time to time to help improve or help mitigate these bugs which arise because of power failures or mechanical problems and can cause all the inconsistencies in the file system data structures and make them corrupt. Sometimes these inconsistencies are very trivial in nature, but over a period of time, they can cause severe data losses. And it's exactly the same reason that Linux supports tools which are there to check the inconsistencies in the disk. Like we can use file system check, which is able to repair inconsistencies in extended 2, 3, or 4 file systems. And for extends file system or XFS, we can use utilities which are XFS_check, and to repair them we can use XFS_repair utilities. Now, just like in the case of make file system, mkfs command that we have seen, which was the front end for mkfs dot whatever file system that we had used over here, like with -t flag. Similarly, fsck is also a front end for commands. If we just type in fsck and the partition number, then it will automatically check what file system type is there, like maybe extended 2, 3, or 4. But on the back end, what it calls is that it calls a routine or program which is fsck dot extended 2 for extended 2 file system type, or maybe 3, or maybe 4. Now, once you restart your system and your certain devices, drives and their partition gets mounted, usually depending upon the configuration of the file system, like the parameters that we have seen in tune to file system for making file system checks, if the numbers have reached, like how many boots have occurred or how much time has passed, this file system check gets run automatically. And the normal behavior, there is another command, another tool besides fsck, which is to fsck, which is just a quick way of performing file system check to make system boot more quickly. The default operation for file system checks for those file systems which are or partitions which are mounted automatically, which are defined in etc and file system table entry, the default count is 20. So after 20 reboots, the disk will get checked until unless we change this option using tune to file system. Also remember and be cautious that if you have got XFS file system, then you make sure that you do not run fsck command on XFS based file system, because it will completely destroy the file system. And why? Because fsck would assume that the file system type that you are running this tool on, it is either of these three. But in fact, it would not be either of these three. It would be a totally different file system. So once you run fsck to check the inconsistency, to repair any errors in XFS based file system, it would try to recover them. And instead of recovering it, it will just play havoc with it and make a mess out of it and make your partition totally destroyed. So just make sure that you do not run, if you run fsck by default, then it is intelligent enough to know that this system type is XFS. But if you use commands like fsck.extended2 or extended3, it will destroy your partition. So let me pull up the terminal and see if we can execute fsck on a drive or a partition. So here we are. I have put the SSD drive in there, and let's just first type in let's just try to tune the file system first. And we can do that by first having a look at what is the current information by putting in sudo dump e2 file system of sdb1 partition. I put in my password, and again I need to use the human readable switch. So let's just try to change this maximum count, which is at the moment it is -1. Let's just try to change it maybe 20. So the command would be sudo tune to file system, and afterwards -c for count. This is small c, and then the number of maximum reboots or maximum mounting counts that should occur before our automatic file system check is kicked in. So I type in 20 and then the partition number, which is sdb1. So now it says that it is setting this value to 20. Let's verify it by using the same command, and we see that indeed it has been changed to 20. Now if you want to run a file system check, make sure that your partition is not mounted. In case of XFS based file systems, you can run that XFS repair command to repair XFS based file system even if your file system is mounted. But for file system check for extended 2, 3 or 4 type of file system, make sure that your partition is not mounted. If it is mounted and you run fsck, then it makes the kernel confused, and it would or corrupt your data very heavily. So just make sure that is not mounted. Now let's try to run file system check on this partition and see if we have got any errors in there. So the command is pretty simple. It's fsck, and if I put in -n, then it is kind of like saying that make a dry run or show us the changes what will be corrected, but do not make those specific changes, so that we can really see that what will be done. And we can also put in a switch which is -y, so that it does not ask us explicitly that whether we want these changes to be made or not. It just does them implicitly without asking them. So let's just type in div/sdb1, and it says that it will actually run the command fsck.extended2, and since this has not found any inconsistency in the state of the file system, so it has not shown us any output. So let's try to run this command, and it says that the system or the file system is clean. Now what I have done is that I mounted this file system on a directory, and I started copying data, and as data was copying I simply plugged out the device. Now hopefully there has become some inconsistency in the file system. Let's hope so, and let's try to run now file system check on this partition, and let's see if it gives us any errors and try to fix it. So the first thing that we need to type in, let's just say if we can find information regarding this file system using dump e2fs command. So I type in dump e2fs and then the partition which was sdb1, or again I need to use the -h flag. Okay, so the information is there, and now let's try to check by using sudo file system check on div/sdb1. So you see it is saying that it was not clearly unmounted, check forced, and checking inodes, and it is also saying that it needs to get fixed. So now this is giving us y. What we can do is that just fix them by putting in -y option over here. But if I want to explicitly see that what it is fixing, I can omit that option and press enter over here, then again enter, and once it gets done with all the changes, it will say that the file system is fixed, which it has. And now if we run this command again, let's just get out of here. Give it a while, and now let's try to run this command one more time. Doing it again, and now the file system is clean. So it did fix some inodes information and superblock information in there, and this is what really happens, that if a system which is extended to it is improperly shut down, or there is some hardware failures in the drive itself.